Cycling in nature. This video I will discuss two of the biogeochemical cycles, the hydrologic cycle, aka the water cycle, which hopefully you remember from your middle school days, and the carbon cycle. What you should be able to describe after watching this is how do elements actually move in an ecosystem? What are the major processes of the hydrologic cycle or the water cycle? And what are the major processes of the carbon cycle? How is carbon actually moved in our environment? And where is most of the world's carbon actually stored? Ecosystem structure is influenced by the availability of nutrients and energy. The five main elements that plants use are carbon, hydrogen, oxygen, nitrogen, and phosphorus. Of these, we will discuss the carbon cycle, and then the oxygen and hydrogen we combine together for the water cycle. Elements that are essential for life usually move in cycles. So when we talked about energy flow, energy was a one direction. It went from producers up to consumers, up to next level consumers, and so forth, and never went back into the producer level. Elements, however, can cycle because matter cannot be created nor destroyed, and the elements, the hydrogen, the oxygen atoms actually do get recycled back into the environment. That is the role of the decomposer, is the decomposer actually has to help recycle these things back into the producer level. Matter and elements flow from one part of the environment to another through biogeochemical cycles. They're known as biogeochemical cycles because it connects the biological, where are the elements actually in life, the geological, how are they stored in the actual rock or in the earth, and the chemical, how are they stored as chemicals. So that's why they're known as biogeochemical cycles, because it shows how the elements are actually cycled between each three of those phases of the biosphere. The first one we'll discuss is the hydrologic or the water cycle. The key thing you need to understand is that the water cycle is driven by solar energy, which you should already know. Sun causes evaporation. Without sun, you might get precipitation. So the sun is the main driver of the water cycle, the hydrologic cycle. So you can see this is a picture of the hydrologic cycle and all the different things. You have evaporation, transpiration, which releases water into the atmosphere. You have condensation when those water droplets condense, or water vapor condenses into droplets to form clouds. You have precipitation when it returns, falling back to Earth. You have runoff. You have percolation where it bubbles through the ground into our aquifers. Then you have water actually flows in the underground in the groundwater flow, and that eventually dumps into the lakes and the streams, which dump into the ocean. So all of this should be fairly familiar to you. What are the two ways that water moves into the atmosphere? You have evaporation, where the water changes from a liquid to atmospheric gas, so it becomes water vapor, which is due to the sun, obviously. And then you have transpiration, which we discussed with the plants. So transpiration is when water evaporates out of the leaves. So remember, the leaves have openings called stomata. When they're open, water can evaporate out. And remember, it creates that suction through cohesion, adhesion, and capillary action that actually causes water to be sucked up from the roots. So the two ways that water can move in the atmosphere is you have evaporation and transpiration. Now, once you get into the atmosphere, how does it actually fall back to Earth? You have condensation, the water condenses and forms clouds. Then you have precipitation, where the water then falls back to Earth. And actually that water that falls back to Earth will remain on land for about 10 to 120 days until it is again evaporated up into the atmosphere. So it is a constant cycle of evaporation, condensation, and precipitation. Some of it is also carried into rivers and streams where it can go into the ocean where that evaporation begins again. Not only is water moving, but water also carries other things. So water is actually an important way that other nutrients actually can move in and out of ecosystem. It can carry phosphorus, it can carry nitrogen, it can even carry carbon. So as the water goes through the hydrologic cycle, it can actually carry nutrients with it. That was the hydrologic or the water cycle. Hopefully that was a brief review from middle school. The rest of the other cycle that you need to know is the carbon cycle, which is how carbon moves through the atmosphere, through the oceans, through the organisms, and then back to the environment as dead organisms when they deteriorate. So how does carbon actually enter the atmosphere? Well, we have respiration. Remember, cellular respiration takes in oxygen, releases carbon dioxide. So when we respire, when we breathe, we're releasing carbon dioxide, we're releasing carbon into the atmosphere. When we burn fossil fuels, when we burn oil, we burn gas, we're releasing CO2, releasing carbon back into the environment also. And also when there's volcanic eruptions. When there's an eruption, you're releasing the carbon that's stored in the rocks deep in the Earth's crust. So all three of those processes release carbon into our atmosphere. Here's a picture of the carbon cycle. So we said fossil fuel burning over here on the right, that releases CO2, releases carbon to the atmosphere. You have decomposition respiration, which releases CO2 and carbon into the atmosphere. You have photosynthesis, which actually takes in the carbon. So photosynthesis is actually how we get the carbon out of the atmosphere. And there's also sometimes diffusion, where some of the CO2 in the atmosphere actually will dissolve into the oceans, which in that case they can actually move back in to the rock and form coal and oil and limestone. Most of the carbon in the atmosphere exists as a gas, CO2. About a half of that carbon in the atmosphere will actually move into two large holding stations or reservoirs. So a reservoir is a storage area. So there's two main storage areas that you need to know. The first one, which is actually probably not something you always consider, but the oceans. Most of the world's carbon is actually stored in the oceans as dissolved CO2 inside of ocean water. So you do need to know that the oceans store most of the world's carbon. Another good place to store carbon is actually in plants. Plants are taking in CO2 for photosynthesis, so they're actually storing that carbon as sugar for later. So that's why it's important to have lots of plants on the world, because the plants are actually taking in the extra CO2 from the environment and stopping climate change from happening. We said that respiration releases CO2 in the environment. Photosynthesis is the key factor that actually takes that CO2 out of the atmosphere and takes that carbon out of the atmosphere where we don't want too much of it and actually stores it. So photosynthesis is the main mechanism to remove carbon from the atmosphere. In aquatic systems, this carbon is actually turned into shells. So the carbon that is dissolved in the ocean can actually be used to create the shells of clams, of mollusks, and of other shellfish. Eventually, when these die, this carbon can actually be converted into fossil fuel, such as gas, petroleum, and coal. So the shells from the dead clams can actually, over time, turn into the fuels that we use to power our cars.